Okay, we've got some properties practice here. So we're going to go through some problems and see if you can talk about, think about which property is being demonstrated. So number one is, which of these is an example of the commutative property? So we want to think about what does commutative property say? Well, the commutative property, see if you can say it out loud. What does it tell? What does it say? It says you can change the order of the addends or factors without changing the sum, and so clearly that's number one here. All right, that's the top one. They changed the order. 4 plus 7 to 7 plus 4. Both of them equal 11. All right. Now they give these same choices here, which is the associative property. So have you figured out which one it is? It's correct. It's the second one. Right. The second one. If you look at the order, it's 6 plus 4 plus 5 equals 6 plus 4 plus 5. So the order is identical, so not commutative, but they've changed what's grouped together. So this would be 6 plus 4 in parentheses are grouped together. Over here they grouped the 4 and the 5. So this is 10 plus 5 is 15. Over here 6 plus 9 would be 15. Okay, so that's the associative property. Don't change the order, but change the grouping. The identity property for addition. Right? Identity property for addition. Alright, well, it's not either one of these, and it is this one at the bottom. Okay, if you start and end with the identical term, you add 0 and the number stays the same. That's the identity property of addition. I guess that the last one is going to be the inverse property of addition, right? 6 and negative 6 equals 0, any number plus its opposite. Alright, so that's that one. Alright, now this is a property we haven't talked about, but it's pretty self-explanatory. What is an example of the multiplication property of 0? Well, duh, right? Anything times 0 equals 0, that's the multiplication property of 0. How about the identity property of multiplication? Right? Identity of multiplication, which one is it? That's right, it is the third one. Any number times 1 equals itself or equals 3, so that would be the identity of multiplication. Which one is the inverse? Right? The inverse is not multiplying by 1, the inverse gives you 1. So it is the second one. Any number times its reciprocal equals 1, or any number times it's... So 1/3 and 3 are multiplicative inverses. Multiplicative, right? Using multiplication as an adjective, that's multiplicative. What's the proper order for the justification of each step in the problem below? So take a look at the problem below. We've got associative, distributive, commutative, and multiplication property. So number one, what do you think? What have they done between the left side and the right side? So what has been changed? The order in the parentheses. There is parentheses, but it's not associative. It's the order that's changed, so that's the commutative property. Alright, so that would be number one. Can we move that? Alright, secondarily, now, from here to here, they've changed instead of the 12 and 10 grouped together, the 4 and 12. That's a change of grouping. That's the associative property. Then finally, oh, hello. Then going from the regrouping to this, that's going to be multiplication. It's not distributive. And so you're just multiplying here both times. Can the commutative property apply to subtraction? True or false? Yes or no, I guess it says it. The answer is no. It doesn't apply to subtraction, because if you did, you know, let's see, 8 minus 3 minus 6, right, and change it to 3 minus, why does it do that? It's very annoying. 3 minus 8 minus 6. Alright, the first one gives you 8 minus 3 is 5, minus 6 is negative 1. Second one gives you 3 minus 8 is negative 5, minus 6 is negative 11. They're not the same, so therefore it does not work. However, if you change the subtractions, right, and I don't subtract, I add the opposite. So if you change the minus 3 to adding negative 3, So we change this to 8 plus negative 3 and plus negative 6. Right? Now, you can go ahead and change the order of these as long as the 8 will stay positive and the 3 will stay negative and the 6. Now it's an addition problem. You can change the order all you want because commutative property does work, and it will always come out the same. But you can't just change the order of the subtraction terms. Associative property can be applied to division, and the answer to that is no, unless you rewrite division as multiplying by the reciprocal. So 8 divided by 4 divided by 12, and 12 divided by 4 divided by 8. This first one would give you 8 divided by 4 is 2. 2 divided by 12 is 1/6, or 0.166666666666. Repeating, if you're a calculator maniac. This one would give you 12 divided by 4 is 3. 3 divided by 8 is 3/8, or 0.375. If you're a calculator maniac. So they're not the same. Cannot do it. All right? Cannot do it. Nice. Why does it do that? It's very annoying. I apologize. Come on, blue guy. Alright, so my question here is, what property is being shown? What property has been applied? And before you answer, because if you jump answer, you may answer incorrectly. Typically, you may want to use the distributive property here, but that's not what's being shown here. What have they done? Yes, they've changed the order. 3 times x plus 2, x plus 2 times 3. So the order has just been changed, right? That is just the commutative property. Alright, how about this one? What property has been applied here? Again, not distributive. Why? Because there are not 2 terms in the parentheses. It's just 6 times x is only 1 term. So what really has been done, and they don't show you this, so it's a little tricky, is they've regrouped the 3 times 6 and then times x. So they've regrouped the 3 and 6. Instead of 3 times 6 times x, this is 3 times 6 times x, or 18x. So this is the regrouping or associative property. Okay. Add another property to our repertoire, and that would be the property of opposites, multiplication property of opposites, or the multiplication property of -1. Any number times -1 is its opposite. So when you multiply by -1, and then of course if you divide by -1, you get the opposite value. So that's the property of opposites. Multiplying by -1 gets you the opposite. And we use that primarily here. Like, so if we have -y equals 20, that's -1 times y. So you could divide by -1, or just think, oh, well, that's -1 times y, so it's the opposite of 20 is the actual value for y. So y would equal the opposite, or -20. So instead of dividing by -1, which you can do, you can just use the property of opposites to just change the value to the opposite answer. And that's the end of our properties. Hopefully you've done a great job and you are a master of properties. Namaste.